Okay, class, what we're going to go through today is the polynomials, adding polynomials. And so, kind of just, we'll jump into it in Alex. Some of the first questions they're going to ask you will be related to reordering, degree, and then something called the leading coefficient. So, basically what this means is that this equation right here is currently written incorrectly. To write it correctly, what you need to do is order it from your largest exponent term to your smallest. So what we need to do is just identify which term has my largest exponent. In this case, it's 2x to the fifth. So we'd go 2x to the fifth. We're done with that one. And then we're going to go plus 3x to the fourth minus 4x to the third plus the 7. And so this would be the correctly written equation if you were to reorder it. Kind of like simplifying a fraction, but putting it in the right order. The degree is simply you identifying what is your largest exponent. So in this case, our largest exponent is 5, so we have a degree of 5 for this problem. We'll do one more here. If you want to pause the video and reorder it and locate your degree quickly, you can. And then we'll talk about what leading coefficient is. To reorder these, though, it's going to be a 3x squared. Oh, no, it's not. I'm sorry. I missed that. X cubed. So you have a negative x cubed plus 3x squared plus 15x minus 5, which makes our degree then 3 from identifying that guy right there. And then leading coefficient. So when you reorder it, what is the coefficient that is in front of the entire equation? In this case, it's just the negative symbol. So it would actually be the equivalent of a negative 1. So negative 1 is the leading coefficient or leading number to this polynomial. And so when we say polynomial, what we are really meaning, just kind of going a little bit of a definition to it, is poly means many. So like what triggers in my head is, I don't know if this is Latin or Greek, because some word poly means many, or I guess I don't fully know, but many sounds right, so let's go with that. And so I think of like poly, like if you're polytheistic, you believe in many gods, where I think about like the Greek goddess, where you have the god of thunder, sun, wind, you have the god of the moon, all those things. It's polytheistic, so polynomials is just anything more than one. So the other term we have is something for just one term. So in this case, you have one term right here. It has one coefficient, one variable with an exponent. This is going to be called a monomial, because the word, the prefix, if that's right, is mono. So monomial is just one. And so again, monotheistic, if you are thinking in terms of gods and goddesses and things. Monotheism is where you just believe in one god, so monomial. Here you have two terms, which is known as a binomial. And I don't know if this is right, but bi means two, and I always think of bicycle, even though the bicycles start with by, but bicycle has two wheels, so bicycle. Here you have three terms, and this would be a trinomial. Same idea, but I think of a tricycle, right? Because the word tri means three, so three terms. And then anything above that, we usually just refer to it as a polynomial. So technically, this would be a polynomial here. This would be, we will really just refer to this as a binomial when we start multiplying two binomials. And so then a little bit of a refresher is back in our unit. This says 15. I think for us it was unit 6 at the time, where we talked about how you can't add exponents, right? So if you have like an x, let's do an x cubed plus x squared. Those are not like terms, so we can't combine them. It just can't be simplified. This is as simplified as this problem could be. Versus what we did a lot when we did exponent rules is we had x cubed times x squared. And in this case, we could simplify those, and we simplified them by adding the exponents. Because when you are multiplying, we add the exponents. This will really turn into an x 3 plus 2 which would then be x to the 5th, and we could add the exponents. So on the bottom one multiplied, we can, up top, they have to be, in order for you to be able to combine like terms and add them together, they have to have the same variable letter, and they also have to share the exponent. So one that you could combine would be like if you had two x squareds, right? So x squared plus x squared, there's technically a 1 here and a 1 there, so this would actually give you 2x squared. And notice your variable and the exponent on the variable doesn't change. We keep it the same and we just add the coefficients. So right here, I would encourage you to pause the video and identify what are the like terms in these three equations. And then if you can identify like terms, try to combine them. Try to add them up. Okay, so as we look at this, I tend to look for the highest exponent first, so I can see that I have x squared as my highest one. So this is like a 1x squared. Those are like terms, right? Because they share the same variable and they share the same exponent. They have to have them both the same. So a 1 plus 3 gives me 4x squared. Then I would move, kind of alphabetically would be my next one, so I'd have my 3x. There is no other x's, so we're done there. Then I probably could change colors here, plus my y. And then we're done with that one. And then finally we just have our whole numbers, just the 5 and the 2, which would give me plus 7. So this would be our answer here for number 1. Number 2, 2x squared, 2x squared, or sorry, just 1x squared. So that would give me 3x squared. Leave that in green. We'll go to red here. We have xy, 1xy, and a 2xy would give me 3xy. And then let's flip to blue. We'll go 1 and 5. So I don't have a plus 6 here. And the last one is we're going to go 3x squared, and now we have a negative x squared, so that's going to give me 2x squared, which is subtracting 3 minus 1. Negative 4x plus 3x gives me just negative x. And then finally we have 3 minus 7, which would give me negative 4. And here are 2 more problems. This is what you'll kind of see in Alex. I'll do one of these with you. To kind of shorten the video, I'll skip the second one so I can get into the subtraction. These parentheses don't really mean anything at this point. Unless there is like terms within these parentheses, then you would combine those first. But even in that case, the commutative property of addition, it's not going to matter the order that you add these. But so parentheses don't really matter in the addition problems where you notice that the sign in between the 2 parentheses is addition. It'll change a little bit when we get to the subtraction, but what we're looking for here, same thing, is 2x cubed, and you got the cube, so that gives me 3x cubed. Then we have a negative 5x squared, 2x squared, which gives me a negative 3x squared. And then it looks like nothing's going to change with this x here and this negative 1 here. So that would be our answer here. So relatively routine. We're just adding like terms. We're looking for like terms and just remembering that we only combine, we are adding or subtracting the coefficients to terms that are like terms, meaning they have the same letter and the same exponent. Now when we get to subtracting, it changes very slightly. I think the best way that kids were understanding this was through this way I'm going to teach you just in this video. Is this first side never changes. So if you want to rewrite it, I think rewriting these is the best way to keep track of stuff. And you would have these parentheses. Now the most efficient way is that we change this negative sign. What we're going to do is we're going to change that negative sign to a positive sign. And then we're going to put our parentheses back in here. And since we change this, really what we're kind of envisioning is we have like a negative 1 times 3x squared minus x minus 8. And we're going to really be distributing that. And that was one of the ways we showed it. But the shortcut to that is instead of trying to draw this all out, what you're going to do is just change your middle operation sign to a negative or to a positive, and then you're going to flip the sign of everything in the parentheses. So that this is a positive 3x squared, so we're going to make it a negative 3x squared. This will become now a positive x and a positive 8. So we just flipped the signs around. And now it becomes just like before. Now we have an addition sign in the middle here, and everything is been distributed by this negative, right? Because in reality, like when you look at negative 3x, for instance, you're going negative 3x and you're going to go minus and then a negative x, so then a negative x. So when you subtract a negative, what that does is it really turns it positive. And so what we did was we took this and we simplified it by flipping those signs all around. And so that's why we did it. And so to finish this problem out, we got 4x squared minus 3x, we have x squared. Then we have a negative 2x plus 13. All right, let's have you guys try a couple. Why don't you guys try, oh, looks like I didn't erase this one. Sorry about that. Go ahead and pause the video. Try to solve number, oh, sorry, get rid of that. Pause the video right here and solve number 3. And then we'll go through it. Okay, so I'm a little less space here than I'd like, but I'll try to get this to work. I'm going to change this to a positive. And I'm going to go negative 2x squared, whoops, minus 6x minus 10. So then my negative 2x squared would be first of all negative 2x squared. A 6x, that's positive, subtract 6x. That actually, 6x minus 6x gives you nothing, right? It gives you technically a 0x, but then you don't even need to show that because it doesn't matter what value you plug in for 0. Say you plug in a 2. 2 times 0 is always 0. So it doesn't matter whatever x is. If x had a value, that expression doesn't matter because it's always going to be multiplied by 0, which will result in 0. So when you do 6x minus 6x or 8x minus 8x, it always is just 0. It gets rid of the entire thing. You don't leave the x. You don't have anything. It's just nothing. So those canceled out. We did this guy, and then you have a negative 8 minus 10, so a negative 18. So our answer would be negative 2x squared minus 18. And then the last one, I'll work this one too. If you want to pause it and try it, you can. These ones just intimidate kids. It starts to look like you're looking at hieroglyphics because there's so many letters and exponents going on. So with the 2xy squared, we are going to look for anything else in the equation that has an xy squared, in which case there's not, so we just have 2xy squared. We can cross that guy off. Then we can move to the 5x squared. And we have one like term down here, so we would have a 7x squared. Cross him off since we're done with him. And we're focusing on this x squared times y. There's 2 of these ones. We have a coefficient of negative 2 and 7. So we have 5x squared times y. And then our last guy over here is just a 6y. This would be the answer to that guy. So take your time when you're doing those and just focus on the like terms where it has a matching variable and a matching exponent. And email me with questions.